Our problem today is to express this as a single fraction. So what we do, we take each one of them independently and we express them in a fraction form. So in this case, we shall say for this one, let an arbitrary letter like x represent the fraction whose decimal form is 5.3 recurring. So that means x is a number like 5.33333 like that. So we have just written two of those many threes that are supposed to be there. Ask yourself, what can I multiply by on this part so that one set of the recurring number or numbers comes to before the decimal point? You realize the number that's recurring here is one number only, and that is 3. So if we multiply by 10, then the decimal will move from here to here, and by so doing, one of those recurring numbers will come to before the decimal point. So let's multiply both sides by 10. That means 10x will be equal to, when you multiply by 10 here, this decimal moves here, so we shall have it as 53.3 recurring like that. Now subtract x from this. So if we subtract x from that, we need to write this one in a way that the decimal will coincide. So we shall have 5 here, and then 3 recurring here. Remember, these 3's are so many, so you can write as many as you want. You can adjust them to suit what you want. In this case, I've written 1, 3 recurring so that it will subtract. When we subtract it with this one, we shall get a 0. So let us subtract 3 recurring minus 3 recurring gives us 0. Then 3 cannot subtract 5. We borrow 1 from here, making it 13. 13 minus 5 gives us 8. When we borrowed 1 from here, what remained was 4. So we write 4. That's equal to 10x minus x is the same as 10x minus 1x. That is 9x. Remember, this x is like 1x. So 10x minus 1x gives us 9x. For us to get x, we divide both sides by the coefficient of x, which is 9. Right, 9, like that. So this cancels here ones and ones. We remain with x being equal to 48 over 9, which if we write in a mixed fraction form will be equal to 5 whole parts. That's 45. It remains 3, so we shall have it as 3 over 9. But remember, 3 over 9 is not in its simplest form. We can write that as 5, and then 3 cancels here once, cancels here 3 times, so that is 5 and 1 over 3. We come to the second one, which is 4.12 recurring. In this case, you realize 1 and 2 are recurring. We have two numbers recurring. So we shall say, let another letter like y represent the fraction, which when you write in a decimal form gives you 4.12 recurring. 4.12 recurring like that. So that means y, the decimal part for y, or the decimal form for y, can be written as 4.121212 like that, because 1 and 2 are the ones recurring. Let's stop at that. We put the recurring marks there. Now ask ourselves, what can we multiply by on this side so that one set of the recurring digits come to before the decimal point? If we multiply by 10, only 1 will come to before the decimal, because the decimal will move here, but 2 will have not come before the decimal point. Our aim is to have a set of the recurring numbers, which in this case are 1 and 2, to be before the decimal point. And that can be achieved once the decimal moves from here to here. That means we must multiply by 100. Multiply by that 100 on both sides. So we shall have 100y is equal to, when you multiply by 100 here, as I said, the decimal moves from here to here. So we shall have the number being 412.1212 like that, meaning recurring. Then we subtract y from it, that is equal to our y is here, so we shall have the decimal coincide, meaning we shall have 4 here and then 1, 2 like that. Remember, although I've written 1, 2, 1, 2 up here, this can be adjusted because they are recurring numbers. Therefore, you can write many pairs or you can reduce the pairs depending on what you want. In this case, we have reduced them to 1, 2, so that when we subtract, the recurring part will disappear. So if we subtract, you realize 0.12 that's recurring on both sides. When you subtract them, gives you 0 point. Then 2 minus 4 is not possible. We borrow 1 from here, making it 12. 12 minus 4 gives us 8. When you borrowed 1 from here, what remains was 0. And then we have this 4. That is equal to 100y minus y is the same as 100y minus 1y, and that is 99y. For us to get y, we divide by 99 on both sides. So divide by 99, divide by 99. Remember, 408.0 is just the same as 408 because 0.0 does not change anything. So in that case, this cancels here once, it cancels here once. We remain with y being equal to, this cancels here once, it cancels here 4 times. So 99 times 4 gives us, this is 36, carry 3, then 36, 396. So 408 minus 396 remains 12. So that will be 4 whole parts and 12 over 99, which you can simplify by saying 3 cancels here 4 times, 3 cancels here 33 times. So that can be written as 4, this one, and then 4 over 33. 4 over 33. So that means then we can write these ones in fraction form. For this one, we know the fraction part is this. So we shall have 5 and 1 over 3 minus 4.12 recurring in the fraction form is this. So we shall have 4 and 4 over 33. Remember the LCM. Okay, before that, the whole numbers are 5 and 4. So 5 minus 4 gives us 1 whole part. And then for fractions, we have the LCM of 3 and 33 being 33. So that 3 divided by 33 gives us 11 times 1 is 11 minus 33 divided by 33 is 1 times 4 gives us 4. So that is the same as 1 whole part, and then 11 minus 4 gives us 7 over 33. And that is the answer. Thank you.